Hello, welcome to the video. In this in this lesson, we're going to be looking at section 9.4, where we're going to be graphing sine and cosine functions. So, essential question here, it says, what are the characteristics of the graphs of sine and cosine functions? All right, we are going to be looking at trig functions graphed on a coordinate plane. It's going to look different than what we've done in the previous lessons because what we are going to do is kind of understand what a sine and cosine graph looks like and how it ties in to the unit circle. So if you um, if you can remember, or at least uh, look up, when we have sine and cosine, basically we are looking at points going from 0 to 360. Okay, 0 to 360. But because when we are dealing with trig functions in this coordinate plane sense, we are dealing with uh, values between 0 and 2 pi. All right, 0 and 2 pi is the same between 0 and 360. Okay, now there is going to be several different points that we're going to be asked to look for. More specifically, there's going to be 5 points, all right? And it, depending on which trig function we're given, whether it's sine or cosine, determines which of these 5 points are we going to be looking at, all right? Of the 5 points, it is, in a general sense, with respect to the unit circle, we are going to be looking at x-intercepts. We're going to be looking at maximum values of these functions, and we're going to be looking at minimum values, all right? Depending on what we're looking at, whether it's sine or cosine. So if I had a sine function in a general sense, we are going to have 3 x-intercepts, and I'm going to show you what they are with respect to a formula. When you have a maximum value for these uh, functions, we are going to have simply 1 maximum value, and for sine, you're going to have simply 1 minimum value. For cosine, we are going to have 2 x-intercepts. We are going to have 2 maximum values, and we're going to have 1 minimum value. Okay, so one of the things that we're going to look at is when we get out our graphing calculator is what both of these functions are going to look like. So when we turn it on, first off, you got to make sure that your mode, that sometimes it might be in degrees, you have to make sure they're in radians, all right? It's not going to graph correctly in your graphing calculator when it's in degrees. So make sure that it's in radians. So if I simply just put in the sine of x, all right, here is our trig function for the sine of x. And so you notice there's kind of these loops. Okay, so if let's say I tried to zoom in a little bit here, and I might get a little too close, but that's, you guys can get the general idea. So what we have here is, right now it only shows 2 x-intercepts, but you will see 3. Basically what this means is how many x-intercepts do you have in a period of this function until it repeats itself. If you notice, it repeats itself as it goes to negative infinity, as it goes to positive infinity. But we have some values here. So if you like notice here, whoop, let me get back so like here, this is looks like y is really close to 1, and we have some values for x. And I'm going to show you what those values are with respect to that. All right, so now this is sine in kind of a close-up view. I didn't get all of it, but here's what cosine looks like. So if I go cosine of x, I'll put it with the sine of x so you kind of get an idea of what it looks like. So here's cosine of x. Here it's coming in, and it looks very different, but very much the same. All right. It all is dependent on what our values are, what our results are with respect to the unit circle. So if you notice here, I have an x-intercept of for my sine at the origin, which means that if I put in the sine of 0, I should get 0, which I do. If you notice in the graph here, cosine, it shows up as a y-intercept of 1. So if I put in cosine of 0, I should get 1, which I do because it's from the results with respect to the unit circle. All right. So looking at this and trying to get an idea of what these 5 points are, here is, again, these characteristics in some of the definitions that we're going to be looking at with respect to cosine and sine of x. So when we are looking at these different functions, we are initially, before we even look at those 5 points, we need to identify two different terms. We need to identify the amplitude of our graph, and we need to identify the period of our graph, okay? Because our graph is going to go on and on into infinity, we have to establish where our graph kind of starts and ends before it repeats itself, okay? So if I were to use just our basic function y equals the sine of x, all right? So what we're going to do is we have our x-intercepts, and we have 3 of them. And in this case, it's going to be 0, 0, which we saw. The next one is going to be whatever the period is of our function multiplied by 1/2, 0. And then the final x-intercept is going to be the period of our function, 0. So those are our 3 x-intercepts with respect to sine. If we looked at cosine, y equals cosine of x, our x-intercepts are going to look as follows. There's 2 of them. The first one is going to be the period times it by 1/4, 0. And then the second one is going to be the period times it by 3/4, 0. So those are all the x-intercepts with respect to the general function of sine and cosine. All right, maximum value. All right, maximum value, like I said, there is 1 for sine, and this is going to be 1/4 times it by the period, and then the y value is going to be the amplitude, all right? So whatever this value is here for the amplitude, that is going to be our y value. So I'm just going to put amplitude, all right? For the maximum value for cosine, we have 2 of them. It is going to be 0, comma, whatever the amplitude is. And then the next one is going to be the period times it by the amplitude. Finally, we have our minimum values. Like I said, there's 1 for sine and uh, 1 for cosine. So for sine, it's going to be 3/4 times it by the period, comma, and it's going to be the negative amplitude. And then finally, the 1 value minimum for cosine is going to be 1/2 times it by the period, comma, the negative amplitude, all right? And I would say this will be a nice tool to have as we move forward when we're trying to look for different sine and cosine values, especially when there's shifting involved and specific transformations. This is a nice start to have. All right, this is a nice start to have. All right, so to find your amplitude for a function, for both sine and cosine, it's going to be the value of a on the outside of the function. So a times it by the sine of bx, a times it by the cosine of bx. That value of a, the absolute value of a, is going to give you your amplitude. To give you the period of our function, it's going to be 2 pi divided by the absolute value of whatever happens to be the value of b. So if b is, whatever, that's how we come up with that. And all of these different formulas are going to be with respect to amplitude and period for those trig, sine, and cosine functions. All right, so getting into graphing a trig function. So in this particular one, they want us to graph g of x is equal to 4 sine of x, all right? Identify the amplitude and period, then graph it, all right? So when we graph this, first thing we got to do is find the amplitude and the period. So the amplitude, we said, was the absolute value of a. Well, a is 4, so it's the absolute value of 4, so amplitude is 4. The period is going to be 2 pi divided by, there's nothing for b, so b is 1. So b is just, or I'm sorry, the period is just 2 pi. All right. So it's sine. So what I would do if I were you is I would reference those general terms to kind of help you go about and solve for those points. So we got to find x-intercepts, we got to find maximum values, and we got to find minimum values. So over the first one, it's going to be 0, 0. All right, there's no change in shifting of our graph, so still 0, 0. The next one is going to be the period times it by 1/2. So the period is 2 pi, so 1/2 of that is going to be pi. So it's going to be pi, comma, 0. And then the third one is going to be just the period, comma, 0. So it's 2 pi, comma, 0. So those three main points we've discovered. The maximum value is going to be 1/4 times by the period. So 2 pi divided by 4 is going to be pi over 2, comma, the amplitude is 4, so pi over 2, comma, 4 is our result. Finally, we have a minimum value. Minimum value is going to be 1/2. I'm sorry. It's going to be 3/4. 3/4 times by the period. So 3/4 times by the period is going to be 3 pi over 2, comma, -4. All right, so if I graph these, I got my 0 right here, and I'm just going to go 2 pi right here. So it starts off at 0, 0, and it moves upward, so it's going to look something like this, and then I'll just stop. All right, this is 4, this is -4, and I will just say, like, right here is pi, okay? And that's how we can, and then if you notice, it would just repeat itself. So like it would just keep on going here, and it would just keep on going here in a similar sense. So if you wanted to find values like that were in the red, you could simply add 2 pi to each one of these values, or subtract 2 pi to each one of these values to get those coordinates as well. But that is, the black graph is the general period of this function. So here, they want us to graph 1/2 cosine 2 pi x. So my amplitude is going to be absolute value of 1/2, which equals 1/2. My period is going to be 2 pi divided by 2 pi, which equals 1. All right, so it's cosine. So we still have x-intercepts, we still have max values, and we still have minimum values. We have two x-intercepts. In this case, it's going to be 1/4 times by the period, which is just 1/4, comma, 0. And then we have 3/4 times by the period, which is 3/4, comma, 0 in this situation. We have our max values. We have two of them. It's going to be 0, comma, whatever the amplitude is, which is 1/2. And we have the period, which is 1, comma, 1/2. Finally, we have one minimum, which is going to be 1/2 times it by the period, which is 1/2, comma, negative amplitude, which is negative 1/2. All right. So if I were to graph this, so here's my 0, and let's say this is 1. It's going to start at 0 1/2. So I'll just say like this is 1/2. We'll say that this is negative 1/2. We'll say, and it's going to kind of go something like so. So it's going to kind of go like this and then come on up like so. All right, where this is 1/2, so it's going to be the middle point there. And we have our two X-intercepts and all that good stuff. So again, like I said, it can go on and on longer, both negative and positive, but you just, in this particular instance, you're going to add or subtract 1 from the period to get those values. Okay. Same thing. These are similar situations with different sine and cosine functions with different amplitudes and different values for b to get the period. Again, if you need additional examples, please feel free. I'm more than happy to do so. If you leave a comment or a message. Next is we're going to be looking at sine and cosine with respect to transformations, um, more like a translation. So it's either we're shifting the graph left or right or up or down with whatever the respective values of h and k is. All right. So like most things we've done, our value of h deals with our horizontal translation, and then our value of k is our vertical translation. You know, horizontal left and right, vertical translation up or down. All right. The only difference is they don't call it X-intercepts anymore. They call it finding the midline of the trig function. So uh, when there is a translation, whether it's up or down, left or right, we don't call them X-intercepts anymore. They just call them midlines. It's still the same general formula that we just talked about, but you are going to add that value of h and k where it's deemed necessary. Okay, so for instance, we are asked to graph g of x is equal to 2 sine of 4x plus 3. Okay, so in this particular instance, we have an amplitude of 2, so amplitude is a, so it's absolute value of 2, which is 2. The period of our function is going to be 2 pi over b, which is 4, which is pi over 2. And all we have is a vertical translation where k is 3. Okay, so there's no value of h, so there's no shifting left or right. Okay, so now what we're going to do is we're going to look at those 5 main points, but instead of writing x-intercepts, we're going to write them as midline. So we got midline, we still have max values, and we still have minimum values. All right, so we go here. Before it was 0, 0, but because we have this vertical translation, it's actually now going to be 0, 3. Okay, so there is going to be a trend here. Everything in the midline is going to have a value of 3 in the y value. Next, it's going to be um, the period times it by 1/2. So it's going to be pi over 4, 3. And then the third one, it's going to be the period, which is 1/2. So that's 1/2, 3. So those 3 points are there. Next, we have our maximum value. Our maximum value is going to be 1/4 times it by the period. So 1/4 times by the period is pi over 8 for my x coordinate. Now for my y coordinate, I'm going to look with respect to my midline y value, and I'm going to take 3 and add it to my positive amplitude, which is 3 plus 2, which is 5. Finally, my minimum value comes from 3/4 times by the period. So 3/4 times by the period will give me 3 pi over 8, comma. Now we take our midline y value and subtract it by 2, which gets us 1. So when I get my graph here, first thing I'm going to do is kind of draw my midline value, which is 3. Just make like a little dotted line here. And then I'll go from there. So this is where 5 is. We'll say this is where 1 is. And I'll make my period value where pi over 2 is. So now it kind of looks something like this. So it kind of comes here, it comes here, and it goes there. All right, knowing that this is going to cross here and this is going to cross there, So that's where those, I do apologize for the inaccuracy of how I drew it, but hopefully you guys get the idea. In this situation, we have cosine. So A is 5, so that means my amplitude is 5. My period comes from 2 pi over 1/2, which makes it 4 pi. And in this particular instance, now we have a horizontal translation where h is 3 pi. Remember, it's always the opposite of how it appears. So now we have to take a look at our midline, max, and min. All right, so again, working out all of the values here. So in this particular one, our midline values, there's 2 of them. After doing all the calculations, it's going to end up being 4 pi, comma 0, and 6 pi, comma 0. All right, I understand that this one here says 4 pi. I'll show you what it means in a second. Our max value so it ended up being 3 pi, comma 5, and 7 pi, comma 5. Finally, our minimum value is going to be 2 pi, comma -5. All right, so now here is what this looks like with respect to the graph. So now I got this graph here. Now the midline is actually the x-intercept because we made no vertical translations. So, but here's the thing. Your graph actually starts at 3 pi because h is 3 pi. So then 3 pi plus 4 pi is actually 7 pi. So that is between 3 pi and 7 pi is actually where the period of our graph is going to be located. All right, so here I'll just make a little dashed line to kind of give you an idea. So now it starts off with our max value of 3 pi over 5. So we'll just say like this is 5 over here. Let's just say this is -5. So now it's going to look something like this and like that, where right here is your middle, where it's going to be, essentially well, it's not going to be 2 pi. It's going to be 5 pi. Sorry. This is going to be 5 pi. So this is 4 pi. This will be 5 pi. This is 6 pi. Yep. And then this is 7 pi. My apologies. That should be 5 pi for my minimum value. And then the last graph that we're going to take a look at is when A is negative. So the amplitude doesn't change because the amplitude is still the absolute value of -2, which is still 2. The period here is 2 pi over b, which is 2/3. That ends up being equal to 3 pi. But we have a value of h that is positive pi over 2. All right, so looking at our midline points, so our midline points don't change because there's no vertical translation per se. So this is still going to be 0, 0. This will be 1/2, so 3 pi over 2, 0, and my period, which is 3 pi, 0. All right, now, because I have a negative, what you're going to do is you originally wrote max here. This is now where your minimum value is, but you're still going to use the maximum. You're going to use the maximum formula. The only difference is you're just going to tie your amplitude as a negative number, which it already is. So this one here, it's going to be 1/4 times by the period. So it's going to be 3/4 pi, comma, -2. My minimum is now going to be my maximum. And now this is going to be 3/4 times it by the period. So this is going to be, what, 9 pi over 4, comma, +2. So here you got your graph. The period is, since you have pi over 2, it actually starts at pi over 2. And then it goes to, so the period is 3 pi. So you're going to take 3 pi and add it together. So that turns into what? 7 pi over 2. So your graph will kind of look something like this. So it starts out at 0, 0 and kind of goes up and down from there, where this is 2 and that is -2. Okay. Oh, I'm sorry. This is wrong. That actually should start, my bad. It should actually start this way and go that way and then come down. Yep, because of the -2, it makes a different, it makes the switch. So yeah, so that's where this is the 3 pi over 4, -2, and this is the 9 pi over 4, comma, +2. My apologies. And that is being able to graph sine and cosine functions. Hope this helps. Till next time.